Assalamualaikum warahmatullahi wabarakatuh. My name is Azil Hazib bin Kamrul from class S2/1. Today, our group will be presenting about analysis and design of a bread truss. So, first of all, we need to do the FBD diagram for this bread truss, which is shown in the slide. For point A, we have AX and AY because it's a fixed support. For point G, we have GY only because it is a roller support. And the load given for our group is, for point C, we have 160 kilonewton, and for point E, 170 kilonewton. So after that, we need to do the equation of equilibrium. Total Fs equals to 0, Ax equal to 0, and we can find the value of Gy using the total moment of A equals to 0. So, and then we get the total Gy value is 166.67 kilonewton. And then we can find the total value of Ay using the total Fy equals to 0. Insert the value of Gy in the equation and we get the Ay value, which is 163.33 kilonewton. And then after we do the equation of equilibrium, we start with joint A. So for joint A, we have FAH and FAB. We can find the FAH value first. So total Fy equals to 0. Insert the value in the equation and we get value of FAH is negative 204.16 kilonewton in compression. And then we can get the value of FAB, which is the value is 122.5 kilonewton in tension. And then we move to joint B. We have FBH, FBC, and FAB. So this is kind of easy. We just find the total Fy equals to 0, which means also FBH equals to 0. And then we have total Fs equals to 0. And we can find total of FBC and FAB, which is 222.5 kilonewton in tension. Next, we move to the joint H. We can find the value of FCH, which is using the total Fy equals to 0. Insert all the value we got before and we get the value 204.16 kilonewton in tension. And after that, we can find the total FH, a value of FH using total of Fs equals to 0. Insert all the value we got before and we get the value FHI equals to negative 245 kilonewton in compression. Next, we move to the joint C. And we can find the value of FCD here, which is we use the total Fx equals to 0. Insert all the value we get from this information and we got the value of FCD 245 kilonewton in tension. And then we can get value for FCI using the total of Fy equals to 0, and the value is negative 3.33 kilonewton in compression. Next, we move to the joint I. We have FHI, Fij. So first we can find Fij first using the Fx, total Fx equals to 0. Insert all the information value we got before and we get Fij equals to negative 247.5 kilonewton. And then we can get Fdi value using total Fy equals to 0. Insert all the value and we got Fdi equals to 4.16 kilonewton in tension. Next one, we move to the joint J. We have Fij, Fjk, and Fdj. For Fjk, we can find use Fs, total Fs equals to 0, Fjk equals to Fij. So the answer is negative 247.5 kilonewton in compression. For Fdj, it's the same as total Fy equals to 0, so Fdj is also 0, downward. Next is joint D. To find the value of Fde, we can use the total Fx equals to 0 instead of the value we got before, and we got Fde equals to 205 kilonewton in tension. And then after that, we can get the value of Fdk using a total Fy equals to 0, insert all the value in the equation, and we got negative 4.16 kilonewton in compression. Next one, joint K. We need to find the FKL and FEK value. So first, we can find FKL. Total Fs equals to 0. Insert all the information we got before, and we get the value of FKL, which is negative 250 kilonewton in compression. And after that, we can get value of Fek. Total of Fy equals to 0. Insert all the value we got, and we got Fek equals to 3.33 kilonewton in tension. Okay, that's all from me. Thank you.
Hi, my name is Muhammad Hasif, and I want to present the answer. So on the joint E, on the Fx is equal to 0, we can get the force for EF thrust, which is 125 kilonewton. I get it in positive, so the answer will be in tension. Then on the Fy equal to 0, I can get the force for EL and equals to 208.34 kilonewton. I get it in tension, in positive, so the answer it will be in tension. On the joint F, for the Fy is just Fl, and then Fl is equal to 0. There's no force. So in the Fx is equal to 0, I can get FFg equals to FEF. So FFg is equal to, look at the joint E, we can get 125 kilonewton is in positive, so the answer will be in tension. Then the last one is joint L. Just Fx is equal to 0, and then input all the information on the calculation, and then we get FGL is equal to negative 208.33 kilonewton, and we get it in negative, so the answer will be compression. Okay, the next one is table for all the truss member. We get the AB 1 to 2.5 kilonewton is on tension, BC 1 to 2.5 is on tension, CD 245 is on tension, DE 250 is on tension, and EF is 1 to 5 is on tension. And then FG 1 to 5 is on tension, and then AH 204.16 is on compression. And then next one is HI 245 is compression, and then IJ 247.5 is compression, and then JK 247.5 is compression, and then KL is 250 is on compression, and then the next one is BH is 0, so it's 0 forces, and then the next one is CI 3.33 is on compression, and then the next one is DJ is 0, and then next one is EK 3.33 is on tension, and then the next one is FL on 0 is 0 force, and then the next one is CH is 204.16 is on tension. Then next one is DI 4.16 is on tension, and then next one is DK 4.16 is on compression, and next one is AL 208.34 is on tension, and then the next one is GL is 208.13 is on compression. Alright, last one we have to find the critical member. Question 3, we have to find the critical member. So from the table above, we get the Fmax is equal to 250 kilonewton. So the critical member will be the thrust on DE is equals to 250 kilonewton. And then we have to find the elongation critical member. First, we get that factor safety is 2. So the stress allow is equals to 250 divided by 2, and then we can get the 125 megapascal, and megapascal is equal to Newton over mm square. So on the question of A36 steel, area of A36 steel is equal to force Fmax divided by strength allow, and then we input the Fmax is 250 times power by 3 Newton divided by 125. Then we get the area for A36 steel is equal to 2000 mm square. Then the next one is A572 steel. Just follow the previous answer. If we find the stress allow is equal to 345 divided by 2, and we can get the 172.5 Newton over millimeter square, and then area is equal to 1449.28 millimeter square. And then after we get the area, we have to find the elongation critical member. So we get the modulus of elasticity, which is E is equal to 200 GPa for both steel, and then the elongation is equal to FL over AE, and then we get the length of the DE is equal to 3 meter, which is 3000 millimeter, and F is 250 kilonewton. And then the elongation for the A36 steel is equal to 1.875 millimeter, and then the elongation for the A572 steel is 2.587 millimeter. So that's all from us. Thank you.